Yes, so as I was saying in the last video, describing the time on the stopwatch. Okay, I bet you got that. So let's go to the depth of a beaker test tube in a beaker, which is illustrated by this diagram. You can see compared to the other one which I showed you earlier. I mean the very first one. You see the values are read from 0 down, okay, up through to B1 and B2. But in this other case, which I just showed you now, you see that the values are read from the top, like you see here, down to D1, which is very, very important. You need to take note of that anytime you are given a diagram. If not, if you make a mistake to observation table, I told you, it will affect your graphs, it will affect your slope, and you lose a lot of marks. And I don't want you to lose any mark. Okay, so you need to be extremely careful anytime you're dealing with observations and taking readings from the diagrams and putting it in your observation table. So what are the do's and don'ts of the observation table? Make sure you draw a neat table with quantities written along with their unit in bracket. I told you that earlier on. There's no quantity in physics that doesn't have a unit, except those which we classify as unitary, and it's very rare you see them in the alternative to practical questions. Ensure all values are written to at least one decimal place. I told you, even if it's a whole number, make sure you put a decimal point beside it to emphasize the reading accuracy for that instrument which you are read from. And any multiplication or addition or division or a subtraction must be written in at least 3 decimal places. Okay, this is very, very crucial, especially for multiplications and divisions where you have numbers appearing in more than 3 decimal places. So if you are having any evaluations to carry out in the practical, ensure that it is written to at least 3 decimal. Even if it is not written to if it is a whole number, put a point and then put 3 zeros at the back of the dot to indicate that it is to 3 decimal places, because they will consider this when they are marking. If it is not there, you will lose mark for it. So take note of it, and do not draw more than one table for one experiment. That happens to quite a number of students. They want to separate the table for the graph, the quantities for the graph from the table observation table which they have prepared. The observation table can take close to like 3 or even more than 5 columns. So they feel like, okay, the one that is important which they are plotting on the graph should be isolated. When you do that, you have actually made a terrible mistake and you lose a lot of marks for that. So ensure the units of all derivations are written along their respective quantities. This is very crucial, especially when quantities that involve evaluations. For instance, you're given mass, okay, and then you are given a length, and then you are asked to find an evaluation which is mass divided by length. I told you whatever values you have must be written to 3 decimal places, and then make sure you write the units of that derived quantity, which is m over l, and then the units will be what? Kilogram or gram, as the case may be, per centimeters or per meters, as the case may be, depending on the value that was given in the observation table. So this is very key, and if you do this, and I told you this observation table is actually carries one of the biggest marks in alternative to practical, and even the real practical, which is carried out in the laboratory. So you can't afford to joke and lose any mark in this. Okay, now let's go to the graph plotting. That's like the next one. I'm just going to show you an example of a graph that was plotted by one of the students. You can see I'm going to tell you the key points and the highlights of this and what you need to look out for when you're doing your own. The first one is what the first one is the heading, which is the aim, the title of the graph is very, very important. Though sometimes this and this, that is the current, and then as well as the voltage, they have actually taken that into consideration. So if you don't write this and this is well labeled, of course you will have your marks. But if you don't write, even if you write this and you don't label your graph, you're going to lose mark. So it is better you label your axis, okay, now for you to write the title without labeling the axis. So whatever you write as a label is the representation of the title, which to me is great, really. So this person has gotten almost 2 marks for this, for labeling each of these axes, which is great. Okay, now you can see the scale they chose, which is fantastic. It's on the x-axis or on the current axis. They use 0.1, 0.2, 0.3 equal spacing. Okay, some of you will start with 0.1, then the next one will be 0.11, 0.12, 0.13. That is very, very wrong, and you are going to lose a loss of mark for that, which that is compression. Okay, look at this one too. Every 4 centimeter here, or sorry, every 2 centimeters, 10 units, which is great. So 10, 20, 30, 40, 50 in that order, which is great, and it captures all the point that was plotted in the observation table of that student. Okay, so you need to take your time before you decide on the scale to use. The scale really helps you to plot your points, so you need to take your time. You can spend about 1 to 2 minutes to determine which scale you're going to use and which one is going to help you. Okay, now what are the key points I need you to note here really is that look at the slope triangle of the student. Fantastic, fantastic. Okay, now you can see that it never used any of the plotted point to determine the slope, and the slope triangle is very, very big. And some of the mistakes some of you make again is that voltage, this axis has been labeled as voltage axis, so it's no longer y-axis. This is not mathematics. You need to take that into consideration. And then this one also, this current, which is current axis, is no longer the x-axis. Okay, now look at the slope triangle, very big, fantastic. So it's going to get this full mark for this. Okay, look at this one, is changing what? Voltage. And change the voltage, you can see it is well, illustrated. You can easily trace it from here. This is 10, and then going up here, this is about maybe 50, about 54 or thereabouts. This is 50, this is 60, this is 51, and this is about 51.5. Okay, so of course, like I told you, you can approximate and make it 152, or you can leave it as 51. Is great. Okay, and it has showed that conveniently, which represents the change in voltage. And I also did the same for current. You got this current traced down to this place. This is 0.85, or you can write it as this one is 0.09, or if it's not exactly on that 0.09, it's between 0.08 and 0.09. So he decided to go for 0, which is great for me. And then the second point is 0.85, which is this. And then you can see how the student has illustrated the change in voltage, the change in current. Of course, the slope is what? Change in your y-axis, which is your voltage axis now, and then the x-axis, which is your current axis. And he has drawn that perfectly. So it's going to get all these full marks. And this is what I expect to do. And you can see what he did. This is called line of what? Best fit. Look at all the plotted points. At least it was able to capture, close to like 3 points, so to speak. This point are far away, but this one, and this one are well captured. Okay, very close to this and this as well. So this is a fantastic. And like I always tell you, your point, at least pick 3 points. And the funniest thing about alternative practical, because the practical has been done, you expect that all the points will fall in what? They fall in straight line. It's always very rare that the points are not actually in a straight line. So you need to take note of that. Let's look at this second graph. Really is a bit different from what he did. Okay, but let's criticize this now. Really, he's done a good job. Really, he has labeled the axis. Fine, fantastic. He has labeled the axis, and also of course he has plotted his points. Okay, which is great. So what is left for you just to pick the line of best fit? And like I told you, your line of best fit doesn't have to start from the beginning to the end. Pick 3 or 4 points that are in straight line, and then you mark, and then you draw your line. And when you're drawing your line, you make sure that you use a long ruler. Most of you use short rulers for exam, which to me you lose a lot of mark for that. So use a long ruler, okay, and draw it from wherever the graph starts and to wherever it ends. Okay, make sure it cuts any axis where necessary. So in this case, you're going to have a y or your length intercept. So I'm going to pick this point and this point and this point. Most likely are going to be on the straight line. So I'll just join in and neglect the others. So like I told you, pick at least 3 points and draw a line of best fit. And when you determine your slope, do not use the plotted point to determine your slope. It's very key. Okay, this person did this, finish his work, so automatically going to imagine you, because of time factor, some of you, of course, you're not going to take consideration of your time. You're going to lose a lot of marks if you don't finish your graph. If you don't finish your graph, you're going to lose mark for graph, you're going to lose mark for slope. That's a lot. So you need to be conscious of your time as well. Okay, make sure you finish your work. Do a neat job like this other student has done, which to me is great. Okay, and finish your work. Which is one essence why this alternative practical physics question is very important. I told you, if you want to get an excellent result in this exam, you need to get You need to get as many marks as possible from your alternative practical questions. So let's go to this now. What are the precautions that we state in alternative practical questions? Because we are not doing the experiment, you don't expect the students to say, I avoided error due to parallax. No, that's wrong, because you're not doing the experiment, so to speak. So the word we use, the phrase we use is I would. If it is parallax error, if you are using a meter rule question like the one I showed you initially, look at this one, this case now. In this case, I'm going to make use of a meter rule, obviously, and I'm reading from this scale, okay, this mass scale. So I'm going to avoid parallax error when reading from the meter rule, the stopwatch, as well as the meter scale, which is great. And also, I was also going to note what zero error because of the instrument that you are using. So we're going to note zero error, meter rule, voltmeter, meter, as the case may be, depending on the instrument which we're given to take your observations from. And then you repeat readings for time, depth of figure, etc. to ensure accurate results. Not all conditions you repeat, your readings. It's only when you're talking about time, maybe depth of the beaker, you have to do it twice and all, so you need that. And then if you're doing electricity practicals, of course, you make sure that you ensure tight connections of terminal. That reminds me, there are 3 practicals which I'm going to be giving to you. And I told you on the earlier presentation that you pick one. Now, most times electricity practicals and the mechanics practical come very easy. But in case the mechanics practical proves to be very hard, then you go for the optics. Optics is always the last option because it involves angles. And if you're not a good student of technical drawing, you're going to struggle with determining the angles, deviations, or angles which are measured in the optics experiments. So if you are doing electricity practicals, make sure that you ensure what? I would ensure tight connection of terminals. And if it is mechanics, I will ensure that the experiment is carried out on a rigid support. Of course, when it involves your rotor stand and maybe your balancing or your movement. And then I will ensure sharp image is formed before taking reading. That is if you are doing optics, which in most cases I always advise students to try to run away from. Okay, so I believe with all this that I've exposed you to, you should be able to do your observation table perfectly. Plot a good graph. Of course, get as many marks possible from the graph. Like I told you, observation table carries most marks. Most times between 8 to 10 marks. And then the graph is about 7 to 8 marks. Your slope 2 marks. Make sure you write the formula. Show where the values are. And sometimes you might even be asked to determine intercepts. Like in this case I showed you of this student that didn't finish his work. If you are to draw this line now, it's going to cut this y-axis, which is your length axis. And the intercept in this case will be maybe around 14, between 14 and 12.0. And anytime you are writing an intercept of in a question, make sure you write it along with the what? With the unit. It's very, very important. Okay? And sometimes they will ask you to deduce from the graph. You should be able to deduce. Maybe determine the load when the length is 14.5. So 14.5 on this, you must ensure you trace it. Trace it so that the examiner will see exactly what you're tracing. And then you bring it down. Very key. Show them that you know what you're doing, and this is how you arrive at. So from this now, 14.5 is going to give me about maybe 17.5 or thereabout, Newton. So it's very, very key. Okay. Alright, so I want to thank you so much for listening to this presentation, and I wish you a wonderful exam. Like I told you, the easiest way to get an excellent result in physics examination is to focus more on your practicals, which is always coming at the end of the theory paper. So irrespective of the way the theory paper goes, don't be discouraged. Focus on the practical question and do it to the best of. And please, slopes is not something you share with your friend. It is for your own consumption. Don't let anyone implicate you while you are doing the exam. Your slope triangle, those are the areas where examiners find out students that are involved in examination malpractice. So to cap it all, remember to share this, to subscribe to this channel. Always look out for my updates on practicals, okay, and other educational, instructional presentations. And of course, share with your friends too. Definitely, your friends and your loved ones. It's very, very important. Ensure you share with your loved ones and your friends. Promote my page and help to reduce failure in physics to the barest minimum. So thank you so much for listening. Have a wonderful rest of the day. And of course, your examination, which of the GC exam you're writing, even if it's real WAEC, I wish you all the very best. And I'm sure you're going to share testimonies with me after the exam and when the result comes out. Do take care of yourself.